Hi, in this video, I will introduce to you the UVA landmark dataset. And this is the way that we're going to introduce also assignment 2 for you. And this dataset is collected by your fellow classmate from the previous semester. So you get a benefit of this very unique dataset on to UVA, and it's also help you to use transfer learning to recognize UVA historic landmark. So here we go. So the actual problem statement is that UVA grounds is known for its Jeffersonian architecture and plays in U.S. history as a model for colleges and university campuses throughout the country. Throughout its history, the University of Virginia had won praises for its unique Jeffersonian architectures. So in this assignment, you will attempt to build an image recognition model to classify different buildings and landmarks on grounds. You will earn up to 70 points for the assignment, plus 10 bonus points if your classifier perform exceed 94% accuracy. You feel free to use TensorFlow Keras API or any existing convolutional neural net framework. So that is our problem statement. Let's see how we're going to actually do this. I give you a quick the instructions here. First, you need to load your UVA landmark dataset from my Firebase server. So this dataset comes with over 14,000 images of 18 different buildings on ground. And then you get to code. You use what you learned so far, use your own neural network, or transfer existing framework. This is my recommendation for you. You can write code in Google Colab. In fact, I provided a template for you to start, so you have that already. And finally, evaluate. You had to return the class accuracy on the test sets, which is at 20% of the data set under a random seed. And I set the random seed equal 49. And the reason for that is because I'm a 49ers. I graduate from UNC Charlotte, and we are the 49ers. Not to confuse with the San Francisco 49ers. The maximum point you can earn is 70 points. Again, 10 bonus points. And you accuracy, I think it's 84%, 94% here. Not exactly quite 95. All right. We actually built a successful mobile application for this in my research group. And so we have the app for you. You want to test it out. We actually built the classification and the data collection app all into once. So you can download this mobile app using on iOS devices. I have links here, or on Android devices as well. So you want to go on to that real quick. We have it available on the App Store, so you can download it if you would like. And certainly, if you have questions, my TA and I will be available, right? So what we're going to do now, we're going to go to the assignment real quick. This is a file that will be provided to you, so you can use them, absolutely. And actually, I had code for you to load in the dataset and do some pre-processing already, so you don't have to do this step. Make more convenient for you, right? So let me run this through and then explain to you. The full dataset is pretty big, over 37 gigabyte. And so what you're going to download is actually a reduced size version of it. It's on a lot smaller. This is over 4,000 images now and 18 classes. If you want a real challenge and you want to process this full dataset, feel free to reach out to me. But for the assignment purpose, this small size dataset will do just fine. Right? So using wget, you can download the dataset into your workspace using this Google API. So let's go ahead and download it. Okay, it'll take pretty fast to download. You have good internet speed here. So let's see. Okay, I think it is download, and then after it's download, you can extract it using unzip to extract the content of the dataset. think I'll replace it. Okay, that is on the way. And after that, we're going to do a few interesting pre-processing, right? So you want to download it down. Typically, if you want to download a new data set, you might have to do this pre-processing step yourself. Here I provide with the instructions. You don't have to, but keep in mind that you may have to do that in the future for any other data set. Okay, so we know where's our data set going to store. Most of the stuff in your collab going to be under content, and this is a part of the data set. So you specify the data directory. Batch size is the number of examples you want to load at the time to train. Notice that I'm not going to load the entire data set into memory. In fact, if you're trying to do that, load everything into entire, like all 14,000 images, and you might not have enough RAM for those when you unzip it. So you may want to try it. I tried it before. It crashes collab. That's one of the way you can crash collab. We're not going to do it here. Instead, we're going to do the batch size of 32. So we only load 32 examples from this data set at a time. And the next one is the dimension of the image. Here I use 150 by 150, but depends on the transfer learning framework you use. It might specify a different type of input. So you have to use maybe different dimension for your images here. I put a note there. And then the last two thing is I'm just extracting a data set from the directory. Using image dataset from directories here. I specify my directory. The validation split is 0.02, which is 20%. 0.2, I'm sorry. You specify which one is the training using the C, 49, right? And specify the image height, width, and the batch size. And you do the same with the test set. Only validate it at a validation. We call it a validation, but we're going to use it at the purpose of a test set here. And then similar batch. So let's run that. And you see here, we find over 14,000 images, 18 class. We're going to use 11,000 for training and almost 3,000 for testing. So we have that all in place. So now we're ready for kind of visualization for your data set here. So I specify here all the class name, and this is in correspondence with all the folder in here, right? So you have all the folders name here. This is for all the class names you want to see. Each of the folder have lots of images inside of them, and so for 18 different classes here. So I use this string so that, for visualization purpose, the learning algorithm, all it care about is whether you set up a label, 1 to 18, right? Or 0 to 17, depending on how you want to set it. And now here I'm going to just visualize some data for you for like a batch of data, right? So here's all the images and the associated label, all right? Cool. So you have up to this part. The next one is up to you. You're going to build that classifier, and you're going to try to see if you can classify this data set correctly. Right. So with that said, let's go back to our examples here. And we're going to use transfer learning for this assignment because training from scratch some sort of framework to classify data set at the images here is very daunting process. But luckily, transfer learning with Keras is going to help you tremendously. Right. So you're not going to train a very large CNN from scratch. Instead, you're going to use an existing framework. And in fact, an award-winning framework. Right. So you think about it like GoogleNet, ResNet, Exception, that sort of award-winning networks, right? So the cool thing about transfer learning is, say if you have some existing framework that you train on existing tasks, right? And you have this very well done, very well trained, and you want to use it for another task, say recognizing UVA landmark. What you can do is you can transfer or reuse some of the lower layer of the existing network. And the nice thing about this is all these weight, remember these are just lower representation of the data set. So if you train on some tasks like recognizing ImageNet dataset, many of these weight on the lower level can actually be relevant to recognizing building as well. So you're gonna move these weights over, or you kind of copy them over, and you put them fixed weight. And then on top of that, you're gonna add a few more layers, maybe 1 or 2, and these will be trainable for this new data set, right? And then you're gonna train the weight. So that's essentially how transfer learning works. It reuse the previously trained network, right? All right. So in general, you don't have to implement models like GoogleNet, Inception, or ResNet. Instead, you can load them in. And Kira actually provide a way for you to load in pre-trained model, right? So for example, you can load in ResNet 50, which is a ResNet for 50 layers here, by calling Kira's applications ResNet 50 with weight train from the ImageNet. That's how you can load the model for ResNet. And the caveat about here is depend on the kind of model you want to load. You might have to pick a different input size, right? So for image, for the ResNet 50, the model expecting 224 by 224 pixel image. And so you have to resize your image into that size. So this is a couple of lines of code here to give you the image that the ResNet require at input. So resize and you process the input here, right? And now that we have the training model, you don't really need a lot of training data. For images, you have a data set of 1,000 images is not a lot compared to, say, ImageNet have millions of images, right? So since you don't have a lot of training data, it is often a good idea to reuse the lower level layers of the free-trained model, right? So another example here, I'm going to try to use exception, which is a variation of GoogleNet or Inception. And I'm going to use that exceptions here, weight using from the ImageNet, and I won't include the top layers because the top layer is used for ImageNet. I only need to use the lower weight for it. So I do an exception here. And what I'll do now, I keep adding a few more layers on top of the existing layer. So I added a global average pooling layers here on top of whatever this base model output, right? So imagine you have the output, you're gonna add in one extra layer on the top. And for Keras, you have the syntax where you kind of create a stack by putting one layer on top of the other layer using parentheses like this. So when you see syntax like this, you know that I'm putting one layer on top of the other layers, right? So the average layer will be the pooling and whatever output of the base model. And then my output gonna be another dense with number of classes I want, which in my case for the UVA landmark dataset is 18 using activation softmax, so I get back probability. And then I'll put that on top of the average layer, which I have here. So, and then I can specify my Keras model is receiving the same input at the base model, but the output is what I specify up here. That's pretty much it for transfer learning. You might need to do more fine-tuning and more complicated operation to get good performance for the UVA landmark dataset, but I think I provide you with quite a lot of information to be successful in the assignment. So I think you're going to have fun with this one, especially it's very close to heart, it's very relevant to UVA, and it's also unique to UVA. So as far as the training, there's a few caveats I want to show you, which means that if you want to have train faster, you may want to switch on hardware acceleration to GPU on Colab to kind of create some parallelization. And when you try to train, I would just put a word of caution on the learning rate. So what it means is first, you want to froze all the base layer. You don't want to change the base layer. And you also specify the learning rate at something like 0.2 or something higher. This would help training your top layers first. And then after that, if you want to get to train the entire network, now you unfreeze it, basically set all the layer to trainable to 2. But you want to train at a much lower running rate so that you don't damage the free train weight, right? So I reduce my running rate here to 0.01, which is like a lot slower than you had before. Just think about it. The reason I want to get really slow, I just want to adapt it just a little bit. I want to make huge change to these weight. That's why I set the learning rate really low, right? So I think I give you quite a bit of information already. So good luck and have fun at this assignment, and I'll see you in the next video.